Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, here we have been provided with the orthographic projections of the solid, and using the information available in this front view and the left hand side view orthographic projections, we are required to evaluate the isometric projections of the solid. Now, since in the isometric projections, the front view face, the left hand side view face and the top view face, all these three faces will be clubbed in a single isometric projection construction. So we are required to evaluate the front face dimensions, the top face dimensions and the side face dimensions of this particular solid. Now looking at the solid from the front side, we work out that the length of the solid happens to be 75 millimeter, while the height of the solid it is equal to 80 millimeter. So the front face view dimensions will be 75 millimeter by 80 millimeter. Now the top face dimensions of the solid will be length equal to 75 millimeter and the width it is equal to 60 millimeter. So the top face dimensions will be 75 millimeter by 60 millimeter, while in the side view we are going to observe that the width of the solid happens to be 60 millimeter, while the height of the solid it is equal to 80 millimeter. So we are going to get the dimensions of the side face as 60 millimeter by 80 millimeter. Now in these orthographic projections, since we have been provided with the left side view projections which have been drawn on the right hand side of the front view projections over here, so we have to look at the solid from the left hand side. So this is why that the left face of this isometric construction will be involved with the left hand side view of the solid. And since we know that the dimensions of the left hand side face, they happen to be 60 millimeter by 80 millimeter, so along the isometric x-axis we are going to project the dimension which is equal to 60 millimeter, which happens to be width of the solid. So the width of the solid it is 60 millimeter. So this width of the solid has been projected along the x-axis and the height of the solid will be projected as 80 millimeter along the y-axis. So we can say that the left hand side face will be drawn along this xy plane over here, and once we draw these two isometric edges over there, so the left side view will be completed into this isometric construction. So if this is the left side view, so the front view will be observed on the right hand side. So we know the dimensions of the front view face of the solid. So this happens to be 75 millimeter by 80 millimeter. So 75 millimeter happens to be the length of the solid, while 80 millimeter it is the height of the solid. So along the y and z plane we are going to draw the front face of this particular solid. So this is going to be the front face of the solid. Now regarding the top face, we know the dimensions of the top face. The top face dimensions happen to be 75 millimeter by 60 millimeter. So 75 millimeter it is the length of the solid and 60 millimeter it is the width of the solid. So along the xz plane we are going to get the projections of the top face of the solid. So the bottom face will be located onto the base, while parallel to this bottom face on the top side we are going to observe the top face of this isometric projections of the solid. Now let us first of all discuss about the basic geometry of this solid. So while we look at the solid from the front view, so we observe that there is a horizontal web in this solid which is having the height equal to 20 millimeter. So first of all we are going to go about the construction of this horizontal web of the solid, right? So this is the element number 1 which is available with us into this solid. Now the element number 2, it is this vertical web. So we can see that there is a vertical web over here which is lying on the rear side of the solid. So this is the front side of the solid, this is the rear side of the solid. So onto the rear side of the solid we have got a vertical web which is going to have this length equal to 20 millimeter and the height, it is equal to 60 millimeter. So this is the height equal to 60 millimeter as we can observe from the left hand side view, and this is the length which is equal to 20 millimeter. Now element number 3, it is a projected square surface. So this square surface is having the dimension 30 millimeter and it is located centrally in front of this square block. So this vertical web is nothing but it is a square block having dimension equal to 60 millimeter, and this is the length or the thickness of this vertical web which is equal to 20 millimeter. So this particular square block which we are going to have over here, so this is a square prism we can say. So this square prism has been located centrally in front of this particular square block, right? So this is a square vertical block, and in front of it centrally we have located another square prism over here which is having edge equal to 30 millimeter, and the length of the square block or the square prism, this happens to be 40 millimeter. So this way element number 1 horizontal web, element number 2 vertical web, and element number 3, it is a square prism or a square block or a square web. So this will be plotted in this sequence. So all these 3 elements we are going to draw over here, and finally in the bottom web we are going to have a slot over here which is again a rectangular slot, and the dimensions of this angular slot, they happen to be 30 millimeter, it is the width of the slot, and 10 millimeter, it is the height of the slot. So in the front view this slot will not be visible. So in the orthographic projections we have drawn a hidden line or a dotted line corresponding to this surface of the slot, and this slot is visible to us in the left hand side view, right? So this is the basic geometric construction of this component. Now in order to draw the isometric projections we are required to convert all these true length dimensions which are available in the orthographic projection view into the isometric length dimensions over here. So all these true length dimensions, they will be plotted along the true length scale, and the corresponding isometric lengths will be evaluated, and once we have evaluated the isometric lengths corresponding to all the dimensions which are available with us in the orthographic projections, only then we can start with the construction of the isometric projections of the solid. Now let us start with the isometric projections of the solid. Now step number 1, we are required to draw a horizontal ground line or a datum line. So this is the horizontal ground line that we have drawn. We are going to mark the center point over here or the starting point. So with this starting point or the center point, this is called origin. So through this origin towards the left hand side we are going to draw the isometric x-axis at an angle of 30 degree. Similarly from this origin point we are going to draw the isometric z-axis which will be inclined towards right hand side at an angle of 30 degree to this horizontal datum line. Then from this origin once again we are going to draw the y-axis which is going to represent the height of the solid, right? So this is the y-axis, and this y-axis has been drawn perpendicular to this ground or the bottom base over here. Now having drawn the x-axis, y-axis and the z-axis, now we have to start with construction of the isometric projection. So we have already evaluated this face will be corresponding to the left hand side view because left hand side view is available with us, and which has been drawn on the right hand side of the front view. So this face we are going to draw the front view of this particular solid. So we know the dimensions of the front view face of the solid, that is length equal to 75 millimeter and height is equal to 80 millimeter. Now we are going to mark the length over here as 75 millimeter. So this length of the solid is marked along the z-axis and this distance is equal to 75 millimeter. And this y-axis, it is going to represent the height of the solid, and the height of the solid we already know it is equal to 80 millimeter. So this is the isometric y-axis, this is isometric z-axis. So within this YZ plane, our front face of the solid will be located. Now in order to complete the front view face, I need to draw another isometric line parallel to the y-axis, and this isometric edge will be having the dimension equal to 80 millimeter. Similarly, another isometric line or the edge I need to draw over here parallel to the z-axis over here, and this isometric edge will be measuring 75 millimeter. So this completes the construction of the front view face of the solid. Now looking at the solid from the side, so we work out that in the side view we are going to have the width of the solid which has been drawn along the x-axis. So along the x-axis we have marked the width of the solid equal to 60 millimeter. So this is the width of the solid which we have obtained from the left hand side view of this construction. Now the height, it is equal to 80 millimeter. So this is the height equal to 80 millimeter. So in order to complete this left hand side view, another isometric line has been drawn measuring 80 millimeter parallel to the y-axis, and another isometric line has been drawn over here measuring 60 millimeter and parallel to the x-axis. So this completes the construction of the left hand side view face of this particular solid. Now let us complete the top view face of this solid, and we know that the top view face is having the dimensions 75 millimeter length and 60 millimeter is the width over there. So in order to complete the top view face, I have drawn another isometric edge over here measuring 75 millimeter parallel to the z-axis, and this is another isometric edge measuring 60 millimeter which has been drawn parallel to the x-axis. So this completes the construction of the top view face over here. Now we have to draw the bottom face of this particular solid or the bottom of the solid. In order to draw the bottom of the solid, another isometric edge measuring 80 millimeter has been drawn parallel to the y-axis, and one more isometric edge has been drawn measuring 60 millimeter parallel to the x-axis, and finally this is the isometric edge measuring 75 millimeter has been drawn from this point, and this edge happens to be parallel to the z-axis. So this completes the construction of a rectangular prism which is going to contain all these three elements of this particular solid over here. Now having completed the construction of this rectangular prism, now we are going to once again divide this solid into multiple elements. So this is my element number 1, which is the bottom web or the horizontal web. So this web is having the length equal to 75 millimeter and the width is equal to 60 millimeter and the height is equal to 20 millimeter. So I am going to draw a ring over here at a height of 20 millimeter from the base. So this is the 20 millimeter distance from the base, and this ring will be becoming my guidance vector to determine this horizontal web over here, right? So with the construction of this ring, I am able to obtain this horizontal web, that is the element number 1. Now having obtained this horizontal web, now I am going to move to element number 2. So this is my element number 2. So element number 2, it happens to be a vertical web, and this element number 2, that is the vertical web, is having the length is equal to 20 millimeter. So this is the length of the solid along the z-axis. So this 20 millimeter length I have marked from the rear surface. So this is the rear face of the solid, right? And this is the front face of the solid. So from the rear face of the solid or the rear end of the solid, I am going to move forward towards the front end by a distance of 20 millimeter. And once I measure this distance, a projection line which will be parallel to this x-axis will be drawn over here, and this is going to define the top face of this vertical web. This is the horizontal top face of this vertical web, which is appearing as an edge view over here. And in the left side view, it is this edge that we have been able to obtain. When we look at this from the left hand side, this rectangular surface, it will be appearing as a straight line or an edge view over here onto the profile plane. So this way, the top surface of this vertical web has been obtained. So having obtained this top surface, now I need to bring the vertical projector from this point and vertical projector from this point onto this ring, onto the top surface of the ring, so that the vertical, you see, distance of this edge, vertical height of this edge, it should be equal to 60 millimeter. It is this edge that I am trying to obtain. So once I am going to draw this perpendicular, so we'll find that this vertical edge has been obtained. And once I draw another vertical projection from this point onto the top surface of the ring over here, so this vertical edge of the left hand side view has been obtained. So it means that this square surface having edge equal to 60 millimeter by 60 millimeter, it has been obtained. So we can see that this is 60 millimeter, this is 60, this is 60, and then once I join this point with this point, so this completes the construction of a square surface over here. So this is a square vertical web which is having edge equal to 60 millimeter, and the true shape of the square web front face, it has been obtained in the left hand side view over here. So this portion has been obtained. Now I move on to element number 3. So element number 3, it is located such that this distance should be 15 millimeter, this distance should be 15 millimeter, this distance should be 15 millimeter, and this distance should be 15 millimeter. Why? Because this square prism or a square web, it has been located centrally in front of the square vertical web, right? So this square vertical web has got the dimension equal to 60, and the square prism which is mounted in front of the square web, this is having dimension 30. So we are left with an offset of 15 from this top end, 15 from the bottom end, 15 millimeter from the left end, and 15 millimeter from the right end. Now these dimensions we are going to plot over here. So please check, this is 15 millimeter from the top surface, we have marked 15 millimeter over here, and similarly 15 millimeter from the bottom surface. So from the bottom we have marked 15 millimeter, from the top we have marked 15 millimeter, and corresponding to these two dimensions, now two horizontal projection lines I can draw. Similarly, regarding the vertical lines, I have marked 15 millimeter from the right side edge, and I have also marked a distance of 15 millimeter from the left side edge. So two vertical projector lines corresponding to this 15 and this 15 will be drawn. Now please check, this is first projection line corresponding to distance from the top. This is second projection line corresponding to the distance from the bottom over here. This is third projection line corresponding to distance from the right hand side gap over here, and this is offset of 15 millimeter from the left hand side vertical edge. So a square has been marked which is going to be my guidance point in order to construct this square prism over here. So this is a square prism or a square web which is having edge equal to 30 millimeter. So I can check this edge, it is 30, this edge, it is also equal to 30, this edge, it is also equal to 30, and this edge also happens to be 30. Now the length of the square prism or a square web, it is equal to 40 millimeter. So starting point of the square prism or a square web has been obtained. So from here, parallel to the z-axis, this is my z-axis. So parallel to the z-axis, 4 projection lines I am going to draw over here, which are going to be having the length equal to 40 millimeter. This is the length of this particular square web or a square prism. So now let me draw it. So this I have drawn with the blue color. Now the front projection, that is the length of this web, I am going to mark with red color, so that you can have proper distinction between the base of this particular square prism and the length of the square prism. So we have marked this length of the square prism as 40 millimeter. So let me draw the 4 projection lines measuring 40 millimeters starting from this point. So this is one edge, then the second edge, then the third edge, and then the fourth edge. So the 4 edges have been drawn having length equal to 40 millimeter. Now I am going to join these edges 1, 2, 3 and 4. So this completes the construction of the square web. So element number 1, horizontal web, element number 2, vertical web, element number 3, that is square web over here. All these 3 webs, they have been drawn. Now we are left with this rectangular slot which is available in the bottom web over here. Now we know that again the dimension is 30 millimeter, that is from the left hand side offset is 15, from the right hand side offset is 15 over here. So we have already marked these offsets of 15 from the left side as well as from the right hand side. So we know these positions of these 2 points. Now from here I am going to mark a height of 10 millimeter. So please check, this is the height of this rectangular slot. So the height is equal to 10 millimeter and the width, it is equal to 30 millimeter. So height I have marked as 10 millimeter. So this I am going to mark it over here 10 millimeter, and then I know these offsets of 15 millimeter from left and 15 millimeter from the right. So I can now draw 2 vertical projections with an offset of 15 millimeter from right side and with an offset of 15 millimeter from the left hand side. Now this construction of the slot is also completed, and then this is the back side. This is the bottom portion as the slot is going to extend till the end. So this is the bottom line which will be visible over here. This is the bottom edge of the slot which will be visible. So even the bottom edge goes like this, but since this is covered by this vertical leg of this lower web over here, so we have not shown this particular dotted line, because in isometric projections we are not going to use any of the dotted lines over there. So this completes the total construction of this solid. Now we are going to join or darken the elements which will be visible to the observer. So let us start with the base. So in the base we will be able to see this U-shaped construction which will be corresponding to this view from the left hand side view. So we can see that there is a lower element or a lower web which is containing a rectangular slot. So we get a U-shaped structure over there corresponding to the bottom web. So the true shape of this U-shaped web, it is available with us in the left hand side view onto the profile plane. So the lower element has been drawn over here, and this is the edge corresponding to the base. Having obtained the left hand side view projections corresponding to the bottom element or the element number 1, now we are going to proceed towards the construction of the front view projections of this particular solid. Now as we look at the solid from the front side, so we observe that this portion of element number 1, it is visible to us, and we have darkened this portion. But there is one thing we must note, that this portion of element number 1, it has not been darkened because element 1 and element number 2, so they have been integrated as it is apparent from the front view projection over here. So in the front view orthographic projections, we have got an integrated element 1 and element 2 shown over here. So that is why now we are going to join this vertical web over here, so that there is no discontinuity of the surface. There is continuity of the surface from element 1 to element number 2 over here, right? So this vertical portion of element 1 and element number 2, as it is appearing to us in the front view, has been drawn over here. So this is the vertical portion of element number 2 and element number 1. Right now we want to complete the top face of this particular solid. So this is a rectangular face which is visible to the observer. That is why we have gone for darkening of this particular rectangular top surface of the vertical web. Now we move on to the construction of the square web. Now this is the square web which is visible to the observer. Now we have darkened all the elements of the square web which are visible to the observer. So this edge is visible, this edge is visible to the observer. Similarly, this edge corresponding to the 40 millimeter length of this particular square web, it is visible. This length of the edge, it is visible, and similarly this edge length is also visible, whereas the front square face of the square web will also be apparent to the observer. It will be visible to the observer. So this also has been darkened over here. Now, by looking at this web, we observe that this square web, it has covered or overshadowed certain portion of this vertical web, which is this portion and this portion. So this portion of the vertical web, which is measuring 60 millimeter, has been covered by this square web which has been mounted centrally in front of the square face having dimension equal to 60 millimeter. So whatever portion of this vertical web it is not covered, we are going to darken this portion. So this portion we have darkened. Similarly, corresponding to element 1, so this portion of the top surface of element number 1, this is not covered by this square web over here, whereas the remaining portion of this edge has been covered by this square web over here. So this portion will not be darkened, while we are going to darken this portion of the element number 1, right? So this way we have been able to obtain the isometric projections of a solid, while the orthographic projections of the solid, they were available with us. So this is the procedure regarding the construction of the isometric projections of the solid, by dividing it into number of elements and then by integrating those elements into the combined solid, right? So this is all for today. So we will be continuing with few more illustrations regarding the construction of the isometric projections of the solids in the coming lectures. So thank you very much. Thanks a lot.